Hello. Next is a conceptual question. I will read the question. There are two subdivisions. First subdivision A. An electrostatic field line is a continuous curve. That is, a field line cannot have sudden breaks. Why not? Cannot have sudden breaks. A field line cannot have sudden breaks. It is considered as one of the properties of electric field line. Second subdivision, explain why two field lines never cross each other at any point. Okay. So first one, they cannot have, that means field lines cannot have sudden breaks. Why? Because suppose if it's a field line, there is a sudden break, means electric field has suddenly become zero. There will not be any electrostatic field line only when there is no electric field. So you should be knowing what an electric field line is. An electric field line is a curve so drawn, electric field line is a curve so drawn that tangent to it at any point gives the direction of the electric field at that point. Okay, so it's a curve so drawn that tangent to it at any point gives the direction of the electric field at that point. So what is the field line? It's a path or a curve drawn in such a way that tangent to it at any point. I'll just come back to this. See, if this is an electric field line, at any point if you draw tangent to this curve at this point, this has to give you the direction of the electric field at that point. Suppose if the electric field line breaks, that means there is no electric field. So electric field cannot all of a sudden vanish along the path of the electric field line. Why? Because electric field depends on distance in a particular fashion, depending on the field is due to what configuration of charges. Suppose if it is a point charge, say positive, this is the electric field line. So it will continue and it will terminate at infinity. That is, there will be electric field here, 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 and so on. Because electric field is given by the formula for this positive charge, point charge, kq by r squared. Let us discuss only the magnitude side now. So if the electric field has to vanish, r has to be infinity. So due to point charge, isolated single point charge, if you consider, suppose if it's positive, if you consider the electric field, it will keep on decreasing and finally it will become zero only when you approach infinity. Suppose it is not due to point charge, if it is due to a dipole, then the electric field will depend on, if it's a dipole, it's due to a point charge. Dipole means it will depend on cube of the distance plus some constants here, not plus, some constants multiplied by 1 by r power 3. So again, when electric field has to become zero means r has to go to infinity. It has to be approaching infinity. Somewhere in between it cannot vanish. This is a format of the formula of the electric field. Suppose it is not even due to dipole, if it is a quadrupole, which is two dipoles opposite in manner. When you have two dipoles with dipole moments opposite, that combination is called as a quadrupole. That combination is called as a quadrupole. Quadrupole means what? It's an array of two dipoles. How the dipoles have to be arranged? The dipole moments should point in opposite directions. Then electric field due to a quadrupole again will vary as 1 by r power 4. Again r has to be infinity. This you can call as monopole, variation of electric field with respect to distance, dipole, quadrupole variation. Similarly, it is there for the other higher order configurations also. They cannot cross each other, obviously, because suppose there is one field line, another field line, imagine they are intersecting here. Then what will happen? You can draw two tangents. For this field line, you draw one tangent, say T1. For this field line, at this point, you draw another tangent. So this point, at this point, you can draw two tangents. And the two tangents, the tangent should represent the direction of the electric field. How can an electric field point in two different directions at this location? Not possible. Therefore, we can say that field lines never cross each other. Understand that other than this, there are several properties of electric field lines. For this question, we are only discussing these 2 points. Is it okay? Thank you.